Hey, welcome to another video. This one is going to be a continuation of the homogeneous linear equation with constant coefficients. I'm still doing the higher order equation examples. This one I'm going to start from problem number 26 from the book. Problem number 26 says that the fourth derivative of y with respect to x minus 7 y double prime minus 18y equals 0. So the auxiliary equation is m to the fourth minus 7m squared minus 18 equals 0. So I'm thinking this one can be, can I factor it? If I do m squared times something, the entire thing squared, what two numbers multiply to equal negative 18 and add to equal negative 7? Well, that's negative 9 and positive 2. So m squared minus 9 m squared plus 2 equals 0, right? So that's m to the fourth plus 2m squared minus 9m squared minus 18. So this first one can factor out to a m minus 3 times m plus 3. And then the second one, I can use the quadratic formula, but I'm not going to use the quadratic formula. I'm going to use the Poisson-Low method, which says, actually, I'm not going to do that. No, I don't have to do that. I'm just going to set that equal to 0. Set this equal to 0, and then set m squared plus 2 equal to 0. Which means I have m1 equals 3, m2 equals minus 3, and then this is going to be m squared equals minus 2, when then m equals root 2I with multiplicity of 2. And this is m3. So the characteristic equation, or not the characteristic equation, the general equation is going to be y equals m1, which is c1 e to the 3x plus c2 e to the minus 3x plus c3, which is e to the alpha x. Alpha is 0, and then that's going to be then e to the alpha x is e to the 0 times x, which is 1, times the c3 cosine of beta x plus c4 sine of beta x. So basically I could just write c3 cosine of beta x, which is root 2x, plus c4 sine of beta x, which is root 2x. But this is multiplicity 2, which means I'm going to have C5 x cosine root 2x plus C6 x sine root 2x. And that should be the final answer. So I'm going to do another example. This one is going to be number 27. And the equation is u to the fifth. Well, I'll just write out the derivatives. d5u dr to the fifth plus 5 d4 u dr4 minus 2d3u dr3 minus 10 d2u dr2 plus du dr plus 5u equals 0. This is going to be auxiliary equation. On the right, m to the fifth, 5m to the fourth, minus 2m cubed, minus 10m squared, plus m, plus 5 equals 0. Okay, let's try substituting a 1. So we have 1 plus 5 minus 2 minus 10 plus 1 plus 5. Does that equal 0? Let's see. Minus 10 and minus 2 is minus 12. 5 and 1 is 6. That's minus 6. And that's true. So the first root is m1 equals 1. And now we can divide synthetically. So we have 1, 5, negative 2, negative 10, 1, and 5. Bring down the 1. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. 6 plus negative 2 is 4. 4 times 1 is 4. 4 plus negative 10 is negative 6. That's negative 6. That's negative 5. That's negative 5. That's 0. So then we have m minus 1 times 4, 3, 2, 1, 0. 4 plus 6 m3 plus 4m squared minus 6m minus 5 equals 0. Okay, let's see if we can set the second one equal to 0. Let's try substituting a 1 in here. So I have 1 plus 6 plus 4 minus 6 minus 5. Does that equal 0? We have 6 plus 1 plus 4. That's 11. Minus 11 is 0. So then we have m minus 1 multiplicity 2. So we can again synthetically divide this, I believe, and then we'll find out what the remainder is of that. So 1 And then we'll do 1, 6, 4, -6, -5. Bring down the 1, 1, 7, 7, 11, 11, and that's 5. That's 0. So we got m minus 1 squared times 3, 2, 1, 0. So let's see. Can we factor this by grouping? No, we cannot. Let's factor it again. Let's try guess and check method. Let's try 1. So 1 plus 7. That's not going to work because they're all going to add up to greater. So let's try -1. -1 plus 7 minus 11 plus 5. Is that true? We have 7 plus 5 is 12. -11 plus -1 is -12. So that is true. Which means the second m, this is multiplicity equals 2. M2 is -1, which means that we can divide this equation by -1. -1, and then we have 1, 7, 11, 5. Bring down the 1, -1, 6. Am I doing this right? Yes. Bring down the 1. 1 times -1 is -1. Add that. 6 times -1 is -6. That's going to be 5. 5 times -1, -5. Add that, 0. So then that means that we have m minus 1 squared. Yeah. M minus 1 squared. M plus 1. And then we have m squared plus 6m plus 5 equals 0. And then we can factor this last equation out. So we'll have m minus 1 squared, m plus 1, m plus 2, m plus 3. No, actually that's not right. It's 5 and 1. 1 and 5, because we have m squared, 6m, yeah. And then that's going to be m plus 1 squared. So, let me think. M minus 1 squared, m plus 1 squared, m plus 5. So, that is multiplicity equals 2. And this whole thing is equal to 0, which means the last m3 is equal to minus 5. So let's write the whole characteristic, let's write the whole equation out. The whole general equation is going to be y equals c1, which is 1, multiplicity 2. c1 e to the x plus c2x e to the x plus, the second one is minus 1, c3 e to the minus x plus c4 x e to the minus x, and then m3 is 5. C5 e to the minus 5x, and that should be the final answer. That was quite a long process, so I'm just going to check the answer real quick. What was that, number 27? C1, oh whoops, I didn't put R's and U's. So the final answer is C1 e to the R, which is C1 e to the X. C2 R e to the R, yes, that's right. C3 e to the minus R, C4 R e to the minus R, C5 e to the minus 5R. So that's the right. The only thing is I didn't put R's, and I'll change those as well. And that was easier than I expected it to be, but at the same time, whenever there's a really long problem like that, it's usually like, well, I don't want to say it's usually pretty simple, but I assumed it was going to be simple just because you can guess and check with substituting numbers, and I didn't think it would be that complicated. Turns out it wasn't that complicated. I might as well do this last example. I hope that I don't mess up on this last one and then make the video unusable. So let's see. 2d5x ds5 minus 7d4x ds4 plus 12d3x ds3 plus 8d2x equals 0. So first things, we're going to divide by 2. So I'm going to just write x to the 5th derivative minus 7 halves x to the 4th derivative plus 6x triple prime plus 4x double prime equals 0. So the auxiliary equation, m to the 5th minus 7 halves m to the 4th plus 6 m cubed plus 4m squared equals 0. First thing I want to try is to take out an m squared. So we've got m squared in the front times m cubed minus 7 halves m squared plus 6m plus 4 equals 0, which makes m2 equals 0, m1 equals 0, multiplicity 2, and then m3 minus, oh, that was weird, minus 7 halves m squared plus 6m plus 4 equals 0. Can we factor by grouping? Don't think so. Because if I take out an m squared, it's going to be m minus 7 halves. And then I don't think that it's possible to make an m minus 7 halves with the second term. So let's try substituting a 1 in here. 1 minus 7 halves plus 6 plus 4. Does that equal 0? Let's see. That's 1 plus 6 plus 4 is 11. 11 over 1 22 over 2 minus 7 over 2 does not equal 0. So how about if we try negative 1? Negative 1 minus 7 halves minus 6 plus 4. I have a feeling that's not it either, because that is minus 7, and that's minus 14 over 2 minus 7. That's minus 21 over 2 plus 4. So that's minus 21 over 2 plus 8 over 2, which is not equal to 0. So what about 3? Oh, I'm sorry, not 3, 2. 8 minus 7 plus 12 plus 4. That does not equal 0. What about negative 2? Negative 8. Hold on, I think I just messed this up. I think I messed up the previous equation. So 2 squared is 8, and then that's minus 14, because it's 4 times 7 halves. That's cancels the 2, so it's minus 14 plus 12. I still don't think it's right. Yeah, still not what I'm looking for here. So now I'm going to try negative 2. That's negative 8, and that's still negative 14. Negative 2, negative 12 plus 4. No, that's not right either. This isn't looking good. How can I do this here? What am I missing? This was what I was afraid of, making this video unusable. What else can I try? I can try graphing it, finding the zeros, but that didn't work last time because I was missing complex numbers. Definitely can't synthetically divide by 0. That's not going to work. If I I don't know. I'm going to have to look up the answer because I can't spend too much time on this. This is number 28. What problem is this? M 2 d to the 5 minus 7 8 2 I don't know how they got m plus 1/2 to synthetically divide. I don't understand. There's no explanation for it. So are they saying that if I plug 1/2 into here, if I plug a 1/2 into here, is this going to be it? 1/2, 1/8, 1/4, 7/8 plus, let's say that's 1/2, then it's 3, but I want to do 24/8 plus, if I want to do 4/8, or 4/1, and then I want to do it over 8, 32/8, that's not right either. I don't understand. Or they did negative 1/2. Negative 1/2. Negative 1/8. And that's it's 1/4. There's negative 7/8. Does that equal 0? 32 minus 24 is, well, I think it is, well, that is 0, but, okay. I didn't get that on my own. I had to look at the answer, but, one of the roots is m2 is negative 1/2. So I can synthetically divide that, negative 1/2, and then it's 1, negative 7/2, 6, 4. Add those two together, negative 4, 2, 8, negative 4, 0, which means I have m squared, m plus 1/2, m squared minus 4m plus 8 equals 0. Can that be factored? Product is 8, sum is negative 4. So tired of thinking. I'm going to use the post-law method because I don't think it can be factored if it's not coming to mind right now. Negative b over 2 is 4 over 2, which is 2. 2 minus u plus u equals 8. 4 minus u squared, 8 minus u squared is 4. U equals 2i, which means I have m1, m2, this is going to be m3 equals 2 minus 2i, m4 is 2 plus 2i. Okay, so the general equation then should be y equals c1, which is 0. So c1 times e to the 0x plus c2x times e to the 0x plus c3 is 2 minus 2i is e to the alpha x is e to the 2x times c3 cosine of 2x. Is that right? Minus 2x. No, it's 2. 2x plus c4 sine 2x plus I don't even know what the heck. Oh my god. I don't even know if I'm doing this right anymore. I'm so tired. Y equals, the first one is multiplicity 2, which means I have those two correct. That's fine. M2 is negative 1/2. Okay, that's what I did wrong. I missed something. I don't know if I need those. So that's multiplicity 2, m minus 1/2 plus c3 e to the minus 1/2 minus 1/2 x, and then plus e to the 2x c4 cosine 2x plus c5 sine 2x plus, hang on, oh yeah, oh my god, I can't even think right now. I don't even know if that's right or wrong. I'm going to check the answer. Check the answer on Chegg here. C1 plus C2x plus C3 e to the negative x over 2 e to the 2x C4 cosine of 2x plus C5 sine of 2x. Okay, cool. That's right. Only thing is I didn't put them in terms of S. So that's what it should be. So let me erase this again. C2S S e to the 2S S. So hard to see the S's. I hate writing S's. Okay. Well, that's the example. Sorry I couldn't think straight. It's too tiring. Thank you for watching. If you made it this far, have a good night.